all this up here. Okay, so series. Here we're talking about an infinite series. And if they say just a series, well, it's an infinite series. And infinite series or series is the sum of an infinite sequence. So we're using sequences in series, and so you really got to be careful about keeping them straight. What is what? We talk about the sum of an infinite sequence here. So here's how we denote a series. We denote a series as the sum as n goes from 1 to infinity of a sub n, or sometimes they'll just write the sum of a sub n, where a sub n is a sequence. And you'll see it both ways. Some of the theorems, they just write the sum of a sub n, and that's okay. If we don't write that n is starting from 1 and going to infinity. In talking about series, we'll talk about partial sums. So I'm going to talk about that next. With a series, we also talk about partial sums. And I'm going to give you an example of one. So and in this example, we'll do some partial sums. So here's a series: 1 plus 2 plus 3 plus 4 plus 5 plus ... What would an expression for the nth term be? When n is 1, the term is 1. When n is 2, the term is 2. When n is 3, the term is 3. So the nth term is going to be n. So there's a series, and this I could write it as the sum as n goes from 1 to infinity of n. When n equals 1, it's 1. When n equals 2, it's 2. When n equals 3, it's 3, and so on. So I'm looking at this one and I'm thinking, here's the big question for this chapter. Does this series converge or diverge? This one diverges. It's going to go to infinity. And the more and more terms I add, the bigger and bigger and bigger this gets. And it's going to infinity. So I'll put this series diverges, but we could still talk about something called the partial sums. But we can still talk about partial sums. And a partial sum would be this. Instead of going to infinity, we'll give it a stopping point. So I do something like this. I'm going to put on the side here the first partial sum would be as n goes from 1 to 1 of n. So that n just takes on a value of 1, and that's it. And by the way, we would write the first partial sum, or we write a partial sum, in this case, S sub 1. I use a script S because if I do a print S, it's going to look like a 5, okay? So I'll just do a script S. Here's the second partial sum. It's S sub 2. And it's going to be the sum as n goes from 1 to 2 of n. And what will that be? 3, because it is 1 plus 2 is 3. What about the third partial sum? S sub 3 is the sum as n goes from 1 to 3 of n. So that's going to be 1 plus 2 plus 3, and that will be 6. So one thing I could do is look at some partial sums. In fact, I'm looking at a sequence of partial sums, and then we can kind of examine that sequence. So I'm going to say this. We can form a sequence. Now sequence, that's 11.1. We're going to form a sequence of partial sums. So I would do S sub 1, S sub 2, S sub 3, S sub 4, S sub 5, and so on. And then I can look at whether or not that sequence of partial sums converges or diverges. So I've only done 3 partial sums for this previous problem, so I'll put them in here, and maybe with a little help from you I'll get a few more terms. So for the previous problem, S sub 1 was 1, S sub 2 was 3, S sub 3 is 6. What is S sub 4? 10. How about S sub 5? 15. S sub 6 is 21. I'll do dot, dot, dot. And I can look at this sequence of partial sums, and then we can kind of examine that to see if it converges or diverges. So this is going to infinity. So this sequence of partial sums is going to infinity as the number of terms approaches infinity. The sequence of partial sums diverges, and the sequence of partial sums represents the series. The series, the sum as n goes from 1 to infinity of n, diverges.